All right, today we're going to look at momentum and the impulse momentum theorem. So momentum is our unit of P. It's a lowercase p, not to be mistaken with uppercase P for power. It also has a direction, and it's equal to mass times velocity. In this chapter, direction is very important. It can be the difference between a right answer and a wrong answer. So keep that in mind. Direction is important. Please be specific. If it's going east, tell me it's going east. Don't just say it's positive. Okay. Next, we're going to look at what changes momentum. And we call a change in momentum impulse. Okay. And an impulse is the result of a force applied over a time. You'll remember last chapter, work was force applied over a distance. This chapter, it's force with respect to time. And that is also equal to, because it's a change in momentum, mass times a change in velocity. And because it's a force times a delta time, I could also find the area under a force versus time graph. Okay. So let's try a problem. Let's see how we use this equation that's got all these parts that are equal to one another. So the example I have is I have a bouncy ball with a mass of 0.05 kilograms going in. It's going to hit a wall at 15 meters per second and bounce back at 15 meters per second. It's going to take a grand total of 10 milliseconds. I want to find what is the average force that ball exerts on the wall or the wall exerts on the ball. Okay. So what I do is I look at my impulse momentum theorem. Because my ball is changing momentum, I'm going to use this equation. And I look and I say, well, what two parts am I going to want to use? So because I want to find F average, I'm going to use this part. And because I'm given a mass and initial and final velocities, I'm going to want to use this part. So I'm going to put those two parts together and solve my problem. So I have F average times delta t is equal to m times v minus v naught. And so, of course, force and velocities are vectors, but I'm going to solve for force. So my force average is going to equal m times v minus v naught divided by delta t. Now the most important thing in this chapter is direction, so be sure to remember that, because if I look at this and say 15 minus 15 equals 0, you're going to be telling me that the wall exerts a 0 force in order to have that ball bounce off it. We need direction. So this is my initial velocity, and it is a positive 15 meters per second toward the wall. This is my final velocity. It's a negative 15 meters per second, the negative meaning away from the wall. So I plug in my information, so I have 0.05 times final velocity of negative 15 minus the initial velocity of 15, all divided by my time of 0.01 seconds. Convert milliseconds to seconds. And I find out that my average force is 150 newtons, and it's negative. That negative sign means away from the wall. And so I could rewrite this as 150 newtons away from the wall.